What I'm trying to do is I've got a paramotor and carry a handheld aviation radio in my lap. And what I was kind of playing around with is, could I put a homemade dipole? I got a 50 ohm coax that I put the shielding go down here 23 or so inches, and then the center conductor goes up here, 23 inches. Coax comes here in my lap, and plug it in to the handheld radio that I've got. It's an ICOM handheld aviation radio, and I'm just trying to improve. Doesn't have to be perfect. Trying to improve on the rubber ducky that comes with this, and dabbling in a little bit of antenna tuning and testing. Watch the video by a guy named, he goes by the channel name Bonafide Pirate. It's like a 4-year-old video. I'll show you my setup and what I'm looking at. Thanks. Okay, so here's a quick rundown of the electronic parts to do the antenna diagnostics on my homemade dipole that I'm trying to do. The first one to the left is a signal generator, noise generator. It creates an RF signal across a broad spectrum of frequencies. You need a barrel connector and be able to get DC power. This is 9 to 12 volts is the one I've got. It's got an antenna, SMA connector, that where the signal that's generated goes out. You need the RF bridge, and you need the RF bridge. Obviously the signal generator goes into the input. There's a reference port. You need a 50 or whatever you're measuring for, but I needed a 50 ohm dummy load. You need the antenna that you're measuring. This is not the dipole. That's way too big to get here on the video, but this is I call it the rubber ducky antenna that came with my aviation radio. This is just an SMA extension cable. There's a little adapter. This is SMA. This is BNC connector. So there's a appropriate male, female, BNC, SMA adapter. You need to be able to connect all these things up. And then the output from the bridge goes to, and the company is RTL, I think. This is a software-defined radio. Basically takes the RF signal from an antenna or the apparatus here and gets it to a USB port on your computer, laptop, and you can use software there to interpret it and work with it. So I've got the Spektrum software loaded, and I can select the device. It's generic RTL 2832U that I will select, and let's see. The frequencies, I've got it set up for something else, but let's go. I'm going to set it to showing 100,000 to 140,000 kilohertz on the top. So that's the range that I think ought to cover what I want to look at with these. So yeah, 120, 118, kind of in the middle of the range is about right for the antennas that I'm looking for aviation purposes. I'm going to power it with a DC power supply. I'll turn it on. It's set to 10 volts. The input voltage says 9 to 12. Figured that was good, so we will give it some power. We're hooked up, and yes. And if I look, I've got the nothing connected, open circuit on the device under test. I got the 50 ohm load here. Input's coming from the noise generator, and this is going to the output. And I don't know if you can see. Let me scoot this over a little bit better. That's what we're getting across that Spektrum. So I'm going to go to measure, and it's from 10 to minus 90 right now. I'm going to set relative mode and let it pause for a second, sweep across and set relative. So now I've got the 0 line, more or less. So everything's relative to what it was doing there. So I'm following what you said. So now I'm going to plug in, let's turn it this way. Actually, I'm going to plug in my dipole antenna, which I've got. This is all just rope. I've got hanging from here to here. It's just a 50 ohm coax that I've separated the shielding. It just hanging down. Again, it's not meant to be perfect here just yet, but I'm going to plug that in to the device under test. And I don't see any appreciable change on the Spektrum.
It turns out that the RF bridge board that I got off Amazon was defective. It was a design flaw in the unit, and I put up a little video about that. There's a couple of videos that help me figure that out and to see how to do it. So look in the links. That'll be in the description, links to those videos. But eventually I got it up and running. And what I'll do is I'll jump and show you some of the scans and just me talking as I was clipping and tuning the antenna, watching the scans on the Spektrum software. Here is what I'm seeing with my backup, let's call it, dipole antenna that I cut to 23, 24 inches. I actually haven't measured it, and I don't think the shielding element is the same length as the inner core because of stretch and stuff. But looks like it's tuned to what, 120 megahertz or so. And I can't remember if 9 or 10 decibels is about where an acceptable SWR ratio is, then it would say 118 to 122 or something like that. Okay, am I recording? Yes, I am. Here is what I'm seeing with the rubber duck antenna that comes, the little whip rubber ducky that comes with my aviation handheld radio. And this is connected. I drug my paramotor over close to my setup, and I had to use a little coax extension, but this is connected to the homemade dipole, such as it is, that's on my cage, and the elements run over the top of my stainless steel spars that go out on my cage. I've got electrical tape and to try to insulate it from that, but looks like it's tuned for a lower frequency there, 109 and up to 112 or 13. Okay, going to take my wire snippers and clip off roughly ½ an inch off of each end of the dipole. Here, I'm just going to use my finger as a guide for where to go. Right about there. That's off the inner core. And let's see, we're at 111, 112. I'm going to cut it off the outer shielding here. 114-ish. And I would like to be centered, I think up close, most of the frequencies I use are up closer to 122, 126 or something like that as the local airports. So let's go another ½ inch. That's there, and let's take another ½ inch off the shielding, the other element. So that's basically an inch off of both ends. I think I've improved. I'll have to go back and watch this video to see. I can't see the Spektrum readout as I'm doing it, but looks like it's moving to the right. Let's go a little more. Let's take it off the shielded end first. This time. And then off the inner core.
ooh, the scale, I'm getting a lot more, I think that's a lot better, isn't it? Change the scale on me there. That's 120. And let me put the, see if I got my antenna. Okay, let's pause this. Yeah, I'm looking at the frequency that the local airports, the little small ones that I'm around here are 122.7, 122.9, those kind of ranges. The larger Class D airspace is 126.9, let's call it 127. So it looks like if I want to tune to those guys, I could take off a little bit more length off the antenna. Let's take it off the coax shielding in first. There's close to 122. What did I say? 126 is, yeah, 126, 127 is that, and 122 is the local airports, or who are the guys I talk to a little more. I'm going to take a needle off there. There we are. Better. Better power supply, better supply to the noise generator. And let's see, what did I say? 122 to 126. So 122 is right in there, and 126 is right over there. So that's probably as good as I'm going to get with this. I think I'm going to leave it right there. I'm sure somebody that knew what they were doing could measure the ends lengths, but you know, it's going to stretch. Ah, there goes the power again. I bumped it. Somebody could probably do better, but I think this will probably work.